In this video, I'll show a simple technique that will transform your game audio from this.
A meteorite carrying a previously unknown mineral landed in rural Japan.
To this.
Stirring excitement among scientists. The mineral, tentatively named celestium, is being analyzed for its potential use in quantum computing.
After this tutorial, you will be able to create your own complex audio effects that will make your game stand out, just like this example.
A meteorite carrying a previously unknown mineral landed in rural Japan, stirring excitement among scientists.
Development has shattered records across the gaming community with their exceptional tutorials and top-tier content.
Real-time audio filtering cuts down on repetitive manual work, allowing you to experiment and adjust audio effects directly in your game engine. It lets you dynamically respond to in-game events, giving players a richer, more reactive experience. When we think of an audio clip, it's helpful to imagine it as a representation of sound waves, with peaks and throughs corresponding to air pressure changes. These variations are what our ears interpret as sound. To capture this in digital form, we need to sample those vibrations over time. Each blue vertical line represents a piece of information. When audio is recorded, each piece of information is stored one after the other. In this case, our sample rate is 20 kHz. Meaning we have 20,000 vertical lines creating a signal that represents a smooth sine wave. If we introduce the same audio clip but with a reduced sample rate, we immediately notice the number of audio samples we have per second is significantly lower, meaning we have less audio data to work with. Bit depth tells us how precisely we measure the loudness level in every sample rate. Bit depth values are interpreted as series of zeros and ones. For example, if you use the bit depth value of 2, we will have only 4 possible value options to write into the current sample: 00, 01, 10, and 11. Recording at a bit depth value of 4 allows us to store even more details, 16 possible option values to be precise. It should be clear now that having a higher bit depth option allows us to accurately record and reproduce subtle fluctuations in the waveform for greater dynamic range. To put things into perspective, an audio clip recorded in a professional studio is recorded at 24-bit depth, which is 16 million possible precision values, whilst a normal cell phone call typically use 8-bit depth. To keep the data small, ensuring calls are transmitted efficiently over the limited bandwidth. Now that we understand the basics of audio waveform, let's break down a bit crusher effect technique that we will apply with code later on. If you feel like you learned something new today, reward us with a like. Instead of having the original sample rate with a smooth sine wave, we will be discarding every few samples to lose partial information from audio. This turns our smooth sine wave into a blocky wave. Then we simply reduce the bit depth of remaining sample rates. Okay, let's do some coding. Start by creating a new class that will serve as an audio filter. Clear the default code Unity provided us with and implement the onAudioFilterRead method. When onAudioFilterRead is implemented, Unity inserts a custom filter into the audio DSP chain, and the method is called every time a chunk of audio is sent to the filter. If you're curious to dive deeper into how this works, the Unity documentation has some great resources for further exploration. Introduce the bit depth and sample rate reduction variables to our class. We'll use these variables from Inspector to manipulate the effect. Then, within the onAudioFilterRead method, we'll start by reducing the sample rate. Remember, this turns our smooth sine wave into a blocky sine wave, losing the audio detail. Iterate through the data array we receive from the audio system and cache the sample value every time we meet the criteria. If we don't meet the criteria, we'll apply the cached value. This consecutively modifies every few samples into the same value, creating the blocky sine wave. The amount of consecutive samples depends on the sample rate reduction value. In this case, reduction value equals to 5. Meaning we're applying cached value to 5 consecutive samples before we cache a new sample value. Switching back to Unity, we have to assign an audio player component to the same game object for audio filter to take effect. Add an audio clip, and I'll make sure play on awake is checked so the audio plays by default in this case. Running the player, we can test our effect immediately by modifying the sample rate reduction.
A meteorite carrying a previously unknown mineral landed in rural Japan.
Stirring excitement among scientists. The mineral, tentatively named celestium,
I'd like to take a moment to say thanks to our talented friend Mateja, who provided us with handcrafted models for this video, which are being used in her game Go Home Annie. Back in our code, let's crush some beats. First, we have to define the quantization step. Second, we perform this operation for every data value from within the array, so each sample gets updated. Let's take a detailed look at what we have achieved with this. If we break down every step of the calculation, we'll end up with a table looking like this. For example, let's say our current sample value is 0.45. We do the bit shifting first. Then, division of 1 by the bit shifted value. Divide the current sample value with the quantization step to get the factor value. After rounding the factor, we lose the floating points. When the rounded factor is multiplied back with quantization step value, we end up with almost the same value that we started with, which is 0.45. But not exactly. Observing the results closely, we can see the deviation increases as the bit depth decreases. This deviation, known as a quantization error, arises due to the reduced precision in representing continuous values when fewer bits are available. If we switch back to Unity, modifying the bit depth and sample rate values will affect the audio reproduction immediately.
A meteorite carrying a previously unknown mineral landed in rural Japan, stirring excitement among scientists.
The mineral, tentatively named Celestium, is being analyzed for its potential use in quantum computing.
With this knowledge, you can say goodbye to hours spent manually tweaking the audio files. Let us know in the comment section below which effects you plan to implement in your own games. If you're interested in more Unity tutorials, make sure to check out our procedural lightning generation tutorial. That's it for this video. Goodbye until next time.